Thank you. Selamat pagi, good morning. Good morning.
Good morning.
Can we put on the light, please? Why have I put off the lights? Because if some of you are too drowsy, please take a nap. No offense. What am I going to talk about today? How do you react to Industry 4.0? And I'm going to go very fast because I want to keep some time for questions. And I don't want the timer to remind me. So, how are we going to react to what? A, B, C, D, E, F. This is all that we are going to react to. And what gives me the credibility to talk about all of this? What I do in my free time. So, as you can see, I have a lot of free time. So I do a lot of things. My free time, I am a nerd. I studied medicine, so just to give you an idea, when we come to the next slide, I will give you an idea of how medicine has changed. I studied medicine way back in 1970s, and I quit, went to IT. Why? More money. Okay, so let's first define Industry 4.0. Our two previous speakers, Mr. Devudas and irreplaceable Mr. Manoj Menon, have already defined it very well. I'm going to define it from a technology perspective. So first I'm going to give you an example. When I first did medical school, we used to do abdominal surgery. How? By cutting the abdomen, right? And opening it up and doing whatever we could. Now, the latest abdominal surgery, you don't even get inside the abdomen. The robot does it. It's called Da Vinci. It's made by a company called Interactive Surgicals. So what it does is, the surgeon, somebody like me, will sit behind a console, having things in my fingers which are tactile. And I move the fingers. That moves the robotic arm. That goes inside your abdomen. Does whatever job needs to do. Even complex jobs like full hysterectomies, pancreatic surgeries, very minute precision jobs. That is Industry 4.0. So what is the difference then and now? How can you get 0.1 millimeter? Because all human beings, we have a very small tremor. We call it ischemic tremor, which means it is hidden. So our hands cannot be so precise. Therefore, even the best surgeon in the world will have a tremor plus minus 0.25 mm. That's why when you have a robot going there, you can control the tremor. So now think of a very famous surgeon who is very old, who has huge tremor because of Parkinson's. In fact, his hands are tremoring a lot. He can still do robotic surgery. Why? Because when he puts in his gloves, we call them gloves, to do the surgery, he can control the tremor tolerance. And that robotic arm will go in there and not have any tremor at all. So that's what is the difference between all of these and the fourth. So what is the key difference? To distill it down, until the third industrial revolution, humans were thinking. The fourth revolution, the machine is thinking. Not the human. The machine is correcting you. Previously, we were the ones who were correcting the machine. Now the machine is the one correcting you, finding your mistakes, riding or overriding you. That's the difference in the fourth industrial revolution. Let's also define it from a technology perspective. So here's the starting point, which is all of us start bottom, which is at the base level, where you are doing business process optimization, and then you go up one layer for web scale optimization, which is a little different and requires a little more intelligence. Then you go up one more layer, which is the digital transformation layer that everybody talks about, but still you are not at the topmost layer. The digital transformation is where many companies are trying to get to right now, but that's not the end goal. The end goal is this, which is where you have all of these interactive systems talking to each other, making decisions on their own. That's where Industry 4.0 is really going. So if you want to do it in the terms of capacity, it's 1000 megabytes is 1 gigabyte. 1000 gigabytes is 1 terabyte. 1000 terabytes is 1 petabyte. 1000 petabyte is 1 exabyte. 1000 exabyte is 1 zettabyte. 1000 zettabyte is 1 brontobyte. What happens after brontobyte? End of the world. Because you have too much data. Right? So let's go to what are the key technologies and why they should matter to all of you. Number one technology is, that everybody talks about, is AI. So I'm going to tell you a story about AI. What is AI? Why is it different from big data? So big data and AI are both confusing terms. But big data is brute force computing. AI is intuitive computing. In big data, you take all of the data you have for the universal spread and try to analyze patterns using the entire spread, which is brute force computing, which is still linear, which is not exponential, which is not intuitive. All of those terms come from AI side. So in terms of what technologies, the first one is linear technologies. The second one is fuzzy logic, which is AI. So even the platforms are different. In the big data world, you talk about Hadoop, you talk about Spark, you talk about machine learning. In the big data, in the AI world, in the AI world, you talk about technologies like TensorFlow, Caffe. These are not there in the other side, right? TensorFlow is free. How do you learn it? Go to Google, go to Coursera, learn TensorFlow. There is one language that kind of transcends the two sides, which is Python or R. So if you want to be in the forefront of technology, Malaysia should invest in these exponential technologies or invest human resources so that they can learn and get the industry to the next level. So that's the difference between AI. And you can see the number one area where AI is going to work is travel. Why? Because in the travel industry, things change on the fly. And there is no big data to tell you, hey, how do I change all of this? For example, there is a typhoon in Hong Kong. My flight is to Amsterdam. I'm not even going by Hong Kong, I'm going by Maritime. But because some airports are closed, or because my flight has to come from somewhere else, which comes via Hong Kong, my flight is delayed and I'm not even flying Cathay. Because my flight is delayed to Amsterdam, a few of my meetings are delayed. A lot of my other activities are delayed. People who are supposed to see me are delayed. So what is AI going to do there? It's going to reroute everything. It's going to let everybody know. That's the future of computing. Where the machine is doing the thinking, the machine is doing the logistics, the machine is doing the planning. And it's not doing it with a huge amount of data at its disposal. It's doing it with minimal data at its disposal. It is just taking two things, which is current status, desired outcome. So desired outcome is what? For me to meet 10 people. Current status is what? There is a flight delay. Therefore, desired outcome will be x minus 1. Therefore, all of these parameters behind will change. So think about AI in a different light. The next one, big data. Everybody talks about big data, but nobody talks about the story of big data. The story of big data is really in 4 categories. Number 1 category is descriptive. What's the status currently? What went wrong? Why did this not work? That is descriptive. The second one is diagnostic. Why it went wrong? Why did I miss my flight? Why is this product not in the shelves anymore? Why are customers waiting in line when the product is not available? So that is the second one. The first one is descriptive. The second one is diagnostic. The third one is predictive. What can go wrong? What can go wrong if there is a flight delay in Hong Kong? Will strawberries from Australia not reach me when there is no connection between Australia and Hong Kong? That is predictive. The fourth one is prescriptive. What should I do so that something like this will not happen? Or what should I do when something like this will happen? So think about it in a very different light. Big data is not just about getting all of the data and analyzing it, but getting outcomes out of the data. So when I work with the government agencies in Singapore, we try to get the story into the picture. We remove the jargon out of the picture, we get the outcomes into the picture. We want to see what's the result. Maybe the result is not going to be X plus Y is equal to Z. The result is going to be X plus Y is equal to A minus B equal to Z1. When you start off, how do you get X plus Y to Z? It's a mathematical problem, but it's a human problem. Why? Because humans are unpredictable. The machine will predict A plus B is equal to C. The human will have 10 other reasons to tell you why it should or should not be C. Therefore, once you put the human element into your big data analytics, you may get a different outcome. But you have to be prepared and you have to factor it in. That's where the intelligence comes in. Okay, competencies is key for some countries like Malaysia, for instance. 35% of core skills, this is from the World Economic Forum. Both the speakers before me have alluded to this. So what am I going to talk to you about is look at the category in the bottom, 19% ASEAN. Why only 19% of ASEAN compared to say 48% of skills disrupted in Italy? That's because in Italy there is more automation. In ASEAN, the level of automation is fairly low. Therefore, the chances of disruption are fairly low, which is also a threat, which is also an opportunity. It's a threat because it will leave us uncompetitive compared to China. It is an opportunity because it's a chance for us to leapfrog straight into the latest technologies, bypassing all of the middle ones and bypassing all of the mistakes that other countries have made, that other companies have made, that other technologies have made. So this is a golden chance for us to get into the latest and look at which are the countries, which are the areas that are going to be disrupted the most. Financial services with blockchain, with all of the cryptocurrencies. So I wrote a book which has just been published in Singapore. It's called Organ Gold. It's on the underworld of organs trading, human organs trading. And how is that organs trading happening? The entire organs trading business happens in the deep web, on the internet, using computers hacked from people like you and me. And how do people, that's how people don't get caught on the internet. Because when the police go and try to find out, the search stops at you Oscar stops at me and they do the history and say, this guy couldn't have done it. It's just that this computer has been hacked. So think about it. But assume you have to be caught tomorrow. Assume you do something really wrong. The law can come after you saying, you bought this child pornography. You bought or traded kidneys online, even though you know nothing about it. That's where security is the most important part. We'll come to that in a minute. Okay, dependencies. This is Malaysia, this is my company. So what are the strengths in Malaysia? The way I see it as an outsider is Malaysia has fantastic strengths. These are all the strengths that Malaysia has compared to all the other countries around the region. So if you look at competitive labor, Singapore is way down the list. If you look at competitive energy, Singapore way down the list. You look at infrastructure, Malaysia is way up high. Or cost of infrastructure, extremely high. I mean, in Singapore. But value of infrastructure, extremely high in Malaysia. So why is Malaysia not optimizing this or focusing on its strengths to become a world economic power? Because Malaysia lacks three things. One is ability of people who have all of those technical skills so that they can be employed in this sector. Number two is agility to find out, hey, where are the opportunities? Let's go and bag them right now. And the third is adaptability. The world is adapting very, very fast. The latest adaptation is blockchain. The other latest adoption is e-security. So think about e-security as a dynamic security. Why? Because security is a changing paradigm. It's not just cyber security. It's also cyber plus physical plus policy plus attitudinal plus the security of the entire ecosystem. So we'll come to security in a minute, but I just wanted to make a point that if Malaysia fixes the ability, which is the manpower, the agility, which is being able to change course quickly, look at the demands in the market, and the adaptability to figure out which technologies we should bet on, you have a hot seller on the hands. Okay, e-security. This is a new paradigm which is just being trialed right now. This is a map, we call it a heat map, a number heat map of the digit for pi. Pi is what? 22 divided by 7, right? The beauty about pi is that it's the world's largest constant. There are 1.1 trillion numbers of pi which have been mapped by the computer. The beauty is no sequence of numbers replicates itself anywhere. So it's a total random generation of pi, and the other beauty is it can be used for security, which is what is being done to avoid hacker attacks in top government installations in say Israel or even the Pentagon, and other governments are waking up to this opportunity. There is no commercial availability yet. The reason I am showing you this is because I had a chance to go and visit some of these labs. I come from the world of mathematics, and I am going to show you what the number pi looks like. So it starts from 3.22 divided by 7. You can do it on a calculator, which is 3.1415, 9265, 358, 979, 323, 84, 6264, 33, 832, 79, 50, 288, 4197, 169, 3993, 75, 10, 15, 20, 97, 49, 44, 59. So now you know I am a nerd. The reason I am saying this, there is one guy in China, only one guy, who can recite 1,200 digits of pi. Guess who has employed him? The government of China. Why? Because you can do ephemeral security. So what is that mean? Let's say you are the Prime Minister of Malaysia, or you are the CEO of some bank, or you are a CFO of Hazana. Your security is paramount. Because a hacker who gets into your account, because of your high status, can get into anybody's account, because you have access privileges across the company. So what are these companies doing? They are doing ephemeral security. What does that mean? The moment you do a transaction online or you go online, a password is generated from a random 7 sequence or 6 sequence or 10 sequence of pi. And another random is picked by pi from another sequence. Only the machine knows it. And as soon as the transaction is done, that security is void. If you make even a single change in that digit, the security is void. So how can a hacker get into you in such a microsecond point of time? Think about that as the ultimate in data security, especially when you're talking about IoT, you're talking about machines which are doing most of the thinking. Some of you may have pacemakers. Some of the pacemakers send data to the cloud. Some hacker can get into the pacemaker and either increase the pacemaker rate so that you get what is called arrhythmia or tachycardia, which means extremely high beating heart, or it can dramatically slow down. We have tried this in a lab. Why is this important? Because all the pacemakers available in the world today have no security. So as a hacker, I go into the cloud, hack into you, and I slow down your heart rate. We call it bradycardia. You will be dead very peacefully in 20 minutes. People will think heart failure, or what we call myocardial infarction. When you do an autopsy, they say myocardial infarction. Because nobody knows the pacemaker slow down. Think about this, because IoT is part of the future of manufacturing. Okay, so how do you find a partner? These are some slides to give you an idea on what to do if you are a company who is, let's say, in banking or in manufacturing. IT is not your core subject. Therefore, you find a partner who has domain expertise in some of these areas or all of these areas. You don't really need all of the areas, you need some of the areas. Because if you're a bank, you need probably data management, you need government, you need just-in-time, if you're manufacturing. So think about these as domain expertise areas where you're finding an ecosystem of partners. You see, in today's world, no company can do everything themselves. That goes for Amazon as well, goes for Microsoft, goes for IBM, goes for whichever company. They all have an ecosystem of channel partners, of technology partners. So should you as a bank, so should you as a SME, because you work together with your ecosystem. You spread your risk and you get a greater reward. So how do you do that? You find a partner. The key word is partner, not a vendor. What's the difference? The vendor sells you this product and goes away. He doesn't care whether you use it or don't use it, or it gets rusty or whatever. A partner ensures that he gives you the product and ensures that you use it together with him for both of your continued success. So find a partner, for instance, just to give an idea. Find a partner who will do a proof of concept for you free of charge. Because then you know the partner knows his stuff. Then you know that you can trust a partner who can do the work for you. Find a partner who will do pay per use, pay per project, pay per profit, pay per revenue. Think about these terms. So you pay the partner only when you generate a profit. Therefore, he is vested in you and you are vested in him. That's how the future is going to be, and that's the paradigm that I urge Malaysia to take. Number 2, fortify. So fortification is an end-to-end technology paradigm. That's because technology doesn't stop piecemeal anymore. It's an end-to-end solution. So how does it start? It starts with data sources. The data sources can be all of these, or whatever data you have. You have to get that data into a platform that is machine readable. So I'll give you an idea for the healthcare industry. Still all over the world, including in Singapore, including in Malaysia, many doctors write prescriptions by hand. You take the handwritten prescription to the pharmacist. You don't know whether he's given you the right dose. You don't even know whether he can read the doctor's handwriting in the first place. And you go and take the tablet and you die. Who's to blame? The doctor? He wrote the right prescription. The pharmacist? He said he gave you whatever the doctor ordered. So in Singapore there was a case. Just 1 week ago, automatically or due to a system error, everyone who got a bottle of cough syrup, instead of saying take 1 teaspoon of cough syrup, the system sent a message saying take 5 bottles of cough syrup. So cough syrup is probably not that dangerous because you know, but if you are a semi-literate person and you get a prescription from a doctor and it says take this tablet, which is let's say diazepam, which is causing slight drowsiness. You take 5 of those diazepam tablets at one time and go to bed. That's the last time you go to bed. So think about what harm it can do, right? So that's why you have to have a platform that can digest all of the structured or unstructured data. Then you have to extract value from the data. So 90% of the data is junk, for example. So again, going to the healthcare point of view, all of your medical data is repeated multiple times, but maybe the blood pressure has changed a bit. So you have to take that part. Sometimes when we digitize records, we see all of the addresses of the doctors, all of the clinics, all of that data is also put in. And that is junk data. We should know what to remove from there. That's called ETL, extract, transform, load. Then you have to process the data because the data is coming from various sources. It's now coming from wearables as well. So you have wearable data coming from your pacemaker, you have wearable data from your phone, from your wearable device. You have to take that as well. You have to take diet data because if you are a diabetic and you are going to eat 2 cakes every day, you are not going to be a diabetic very soon. You are going to be a kidney patient, or you are going to have what we call